Hi everyone, we're going to talk about proofs today. A proof is probably something you've never worked with before or never heard of before. And if you're still not 100% clear on what it is when we're done with this, that's okay. We're going to talk about it a lot in class. Um, we are going to first talk about how you apply a proof to something we're all very familiar with, which is just a basic, simple equation. And then eventually we're going to apply it to geometry. So get your pens ready or pencils ready and let's go. You might want to stop the video along the way so you have time to write. So the definition of a proof is a list of logical steps with justifications that uses deductive reasoning to show that a particular rule of geometry is true. So deductive reasoning, we're going to go from the general to the very specific to try to prove something. All right, there are two types of proof. The one that I grew up doing and that I'm very familiar with is the two-column proof or the formal proof. So we have formal and we have informal proofs. All right, so a formal proof is called a two-column proof, and it's written in a very organized way. So it's written in a very organized way. So that would be your formal proof. Then we also have informal proofs, and informal proofs are basically a paragraph. You just write down what you did as best you can. It's a proof that are essential steps in a quick paragraph without worrying about every little detail. So it's written in paragraph. And we don't worry about every little detail. All right, they're very informal. Makes sense. These are very organized and very detailed, and these are not very detailed. They're just basically in paragraph form. All right, so let's first talk about formal proofs or two-column proofs. All right, what are they? It's a logic or a list of logical steps and justifications written in a very organized way. So a list of logical steps and justifications written in a very organized way. Okay? A list of logical steps and justifications written in a very organized way. And in fact, this right here is a kind of a template or a layout of kind of what a formal proof would look like. You can see that there's two columns. We have statements and reasons. We also have our given information and we have what we have to prove. So we always start out with something that we're given. Okay, so these are the statements that should be assumed to be true. So we're assuming that those are true because they gave it to us. So this is like when you're working with a word problem, the information that's given in the word problem. They'll always give you some information, and then you have to use that information and your deductive reasoning to help you create a logical list of steps to prove whatever it is they're asking you to prove. So the prove is the thing that we are trying to prove true. Okay, so this is basically kind of our starting point, and this is where we want to end up. All right, so think about an equation. You start out with an equation, that's what they give you, and you're trying to prove or justify what the answer to the equation is, or the variable. Okay, so what is the given? It's statements that should be assumed to be true. That should be to be true. And the prove is what you're trying to prove. All right? It's what we're trying to figure out. Or you could also say, or what you're trying to justify or trying to prove by your steps. I'm just going to write prove. Not quite sure how else to write that. Okay, what is the diagram? Well, a diagram for us right now is, we're going to put it up here, and that's basically going to be an equation. But when we get to our geometric figures, that might be a circle and a triangle, or two triangles, or quadrilaterals, or something like that. It'll be some different shapes, so it'll be pretty easy to draw that. So a diagram is figures that represent the objects the given and prove are referring to. Okay, so see if you can see that. I'll try to zoom it in a little bit for you. See if we can. Okay, so they're basically, it's referencing what they give you and what you need to prove. Okay, that's what your diagram is going to be. What are the statements? Okay, so this column right here is for all your statements. And it says, what are your reasons? Well, that is what goes in this column right here. Okay, so that's what your statements and your reasons are referring to. And I need to move this up. Let me move this up just a little bit so you can see it. Okay, statements. They're the logical steps that are listed in the left column. Okay? And the reasons are the definitions, postulates, I know that's a new word, and properties. Okay, we're not going to talk about postulates right now, but we'll get into those when we dive a little bit further into proofs. But for right now, don't worry about what that word means. just think definitions, properties. You know, we have different properties of algebra that you've learned: the associative property, commutative property, distributive property, all kinds of properties. Okay, so these are definitions, postulates, or properties that justify each of the logical steps. Oops. In the right column. No. Each of the logical steps listed in, and we list them in the right column. Okay, so every statement has to have a reason. Everything we put in the left column has to have a reason that goes with it. Okay, so that's basically how it goes. Up here would be your diagram. And then over here, we usually start out with whatever we're given. The first thing we would put is whatever we're given, and then the reason would always be because it's given. So, and then we would go to step 2 and have a reason for step 2, and then have a third statement, and so forth, and have a reason for the third statement. So it basically would kind of look like this, and I'll demonstrate to you on this problem right here. This is on page 18 in your packet. Okay, so we're given, and I want you to go back and read this on your own. I'm not going to read it to you right now, just so this video isn't so short, or isn't so long, I should say. Your first statement, just like I just said, will always be a given statement, and the reason will always be given because they gave it to you. So make sure that you number each statement and its reason, and add additional statements by building on to the given statement and making sure that you give a reason for each statement. Okay, so we have to do it in a logical progression. Your last statement should be your prove statement. So, for example, let's say we're given this equation right here, 5x plus 2 equals 27, and they want us to prove that x equals 5. Okay, so this is our given, and this is our prove. All right, so the first thing you would have to do is, oh, well, this is an informal proof. Okay, so an informal proof, I would remember an informal proof we're going to write in paragraph. Okay, so let's talk about how that would look. All right, so we're basically going to just write out what would you do to solve this problem. So I want you to stop the video and just give it a go and see what you get. And then when you're done, start the video again. Okay, so I'm going to go ahead and write out what I would write in this informal proof. Remember, this is, since it's informal, you don't have to list everything logically, and you don't necessarily have to include every little detail. You're just basically writing down what's going through your head as you're solving the equation. Okay, so I would say to solve 5x plus 2 equals 27, you need to get x, put it in quotes, alone on one side of the equation. All right, first, what would be the first thing we would do? I think the first thing we would do is subtract 2 from each side. So first, I would subtract 2. from each side. To get 5x alone. Okay? Then what would you do? Well, that would leave me with 25 on the other side of the equation. So I'm going to write that down. Okay, then I would divide both sides by 5 to get x alone. All right, so next I would divide both sides by 5 to get x alone. That would leave me with x on the left side and 5 on the right. And therefore, that little triangle, those 3 dots, that represents the word therefore. That's kind of a shorthand. X equals 5. And that's what I was trying to prove, that x equals 5. So it's just basically a logical paragraph, kind of just explaining what you just did. All right, so down at the bottom are some properties that you need to make sure that you understand. So go back and just review each one of these properties. We will go over these in class, and we are going to practice some of those formal proofs in class. But as long as you have the basics down right now, I think you'll be good to go for tomorrow when we actually start diving into some of these formal proofs on the next page. And we will walk through these together and see if we can figure them out, okay? Just make sure you go back and copy all of that down, and you're good to go. Have a great day.